Hello everyone. Every site has a slope, but how many designers actually know how it works? Think of roofs, ramps, paths, drainage. It's needed in almost any design task. In this video, we will build a slope analysis tool from scratch right inside Grasshopper. No third-party plugins needed. If you don't have time to follow along, don't worry. I will upload a finished script to download for a small fee, link in the show notes. But if you follow along, only then you will really understand how it works. And by the end of the video, you will never look at terrain in the same way. Let's go. And by the way, before we jump in, a big shout out to our 2 new channel members. You guys are legend. You keep this stuff going. First we have Feliz Aleph Sanchanlar, and then we have Alex Maliokas. Feliz, apologize for the long wait, but here we go. You guys, and together with all our other members, you made this video happen. Indirectly, of course, but I would call this a collective slope optimization. Let's jump into Rhino. Alright, so in this video, we will go through the process on building our own slope analysis tool, which you can use for terrains with very big slope changes, or for example, very subtle shifts for drainage analysis. So we will look at the input, what kind of geometry we can input. We will make some tweaks and translate that into meshes. Then we have some math going on to understand the angles. And then a tool here where we can input our slope ratios we want to test. And then we map everything with our own colors back onto the surface, so we understand exactly what the slope degrees are. This is a tool let's say, a very messy version of that tool is what we use every day at my professional work at Hedevig Studio. But I thought, let's bring it into a shape. Let's bring it into a nice shape with bite-sized portions for you to understand how we put this together. All right, I will keep this on the side so I can cheat a bit and look back what we did. But we built our new script. The input. Okay, what do we need to input? First, let's see. So we have these surfaces here. We have a path, a road going through, and we want to understand what are the slope degrees for this terrain. Now, these are just normal surfaces. They are trimmed off. That's perfectly fine. We can use that. You can also use sub-D surfaces or mesh surfaces. At the end, everything will be translated into mesh. So first of all, what I do here is I just use this geometry container. The geometry container allows to put different things into the script. So the next step would be to change this to a mesh. Let's get all these surfaces first in. I'm gonna grab it here and put this in here. We can turn this off. Now I can see what's in my container, okay? So that's in here. Now, the next step would be to change this to a mesh. So we could change it to a mesh like this, from create a surface UV mesh, or what's actually better is to change it with the quad remeshing tool. The quad remeshing tool actually takes the geometry and change that into a mesh too. But it already creates quads for that, which is really useful. So we could just go with this, but what I'm trying to do here, okay, let's have a look on how that will look like. If I want to have a look on how the actual mesh faces look like, we can go here into mesh and get the face boundaries. So I could do this, and you can see it's actually quite nicely organized. There are no triangles in here, and yeah, it works really well out of the box. Nevertheless, we can give it more control. We can go here and get the settings, the quad mesh settings, quad remesh settings, because that allows you to tap into a bit more control. So for example, you could get a slider with a bigger number. If you want to have more a more finer mesh, then you could use this tool, for example. Now, what I would do though is can keep it like this. It's quite nice. And there are more settings here. I think the adaptive size could help you in some cases if your mesh is very complex. But you can go through and of course try all these other settings here. The mesh boundaries give me actually the mesh. It shows me how the mesh looks like. Let's turn this. I'm gonna disable the preview for this, and I also want to disable the preview for this one. I want to only see this at the moment. So the next step would be to combine the meshes. So because at the moment we have 5 meshes in here, we want to join the meshes, still the same, so it hasn't changed, but now we only have one mesh here. By the way, if you want to show these boundaries in a different color, there is a preview for curves. That's pretty handy. So you can place this in here, and we could also turn this off, the preview. Line type, continuous, black, for example. Or you can give it another color. Super handy tool. Now, what else? We want to deconstruct the mesh. Now you think, why? Okay, so we deconstruct the mesh. That gives us quite a lot of information about these meshes. But this is the first step. So we have an input where we place our geometry. That could be, of course, a sub-D surface or a mesh surface. But remember, it asks for geometry. This tool asks for geometry. It takes pretty much everything, anything. So that would be our first tool. Let's group this together. All right. Now, what's the next step? From here, we actually split into 2 directions. One is to rebuild our mesh again, and then the other one is to measure the angle. So we have to measure the angle, we need vectors, and we have vectors in here. So again, I can hide this tool. I don't want to see that. And now I can get certain things out of here. We have vectors in here. What we want to do, we want to unitize the vector. We want to make it all the same length. Very important. And we have unitized them. Now we need to compare that with something. And that could be just a simple set vector, set unit vector. We don't need to really unitize it, but just for the sake of completeness, let's just also unitize that. It's the same, actually it's the same. But if you would, for example, have a different vector as a different direction you want to test it against, then to unitize it is the better way to do. Now, okay, from here, what we want to get the dot product. It's basically a multiplication of these vectors, the dot product. What it really does is to just multiply the x with the x and the y with the y and the z with the z. And that is my dot product. Now, with what the output is the cosine from which we can calculate the angle. For that, we take the arc cosine, get this in here, and we have a result. The result is radians. So we need a tool which we can use to translate radians to degree. So just degrees. The other way would be to write your own equation, but this is also a way to do it. So you could, of course, translate that into an equation and it would be the same. But now we have our degrees. That's the degrees. These degrees shows us the slope angle per face, per mesh face. Now we have created our second tool. We can group that together. If you want, you can even name that angle or slope angle, slope angle, angles. Okay. And yeah, we can also change this to meshing. Now, what else do we need? We need a list of colors. well, we need a list of degrees, slope degrees. So on how that works is we have a list of angles. We have 11,645 angles, and now we need to divide them into ranges of angles. Let's say from 0 to 5 degrees, from 5 to 10 degrees, and so on. So for that, we can just create our own, like a slope degree list. These are typical thresholds let's say, for a topography which looks like this. If I compare this with slope ratios, what I try to do here, I want to create a list which allows me to measure certain ratios. So 0 to 2.8 would be around 1 to 20, let's say, slope ratios. The 1 to 20 is the threshold for ramps. So everything below 1 to 20, so let's say 1 to 18, for example, is steeper, and therefore it needs a handrail. So it's a very clear threshold. 1 to 12 is a threshold where you don't want to have a ramp anymore. That's already quite steep. And 1 to 10 is a ramp you don't want to have, except it's very short. 1 to 6 is a slope. It's still walkable. It's still okay. 1 to 3 is the threshold where like maintenance on a slope becomes a bit tricky if it's steeper than that, and so on. So then from 1 to 2, from 1 to 3 to 1 to 2, you need soil erosion protection and so forth. And then it goes up to 90 degrees. So that's kind of the comparison list to the slope degrees. So this is the resulting slope degrees. Now, of course, you can have your own list, especially when you have very flat surfaces and you calculate your drainage, then you need to modify this list, of course. But I will just show this, how it works with the list. So this tool works with slope degrees, but you can, of course, translate and calculate the slope degrees out of the ratios. So what do we need next? We need consecutive domains. If I put this in here, so I get here, the output is that I get a list of ranges, domains. So now I don't have just a list of 0, 2.68, 2.76, 9.46. I have ranges from 0 to 2.68, 86, from 2.86 to 7.62, and so on. There's something wrong. Actually, we need to go here to false. Very important. Boolean toggle. Oops, that's not what I want. We want this definitely be false, because otherwise it would just add the next domain on top of the other one. So now it's correct. We end up with from 45 to 90 degrees. That's the steepest here. I hope it's clear so far. Now we can map our degrees onto these domains. How do we do that? We need a tool called find domain. Put in here the domains. Oh, by the way, this is our new group. So we can group this together. And now with this one, we can map our list of angles to the domain, to the domains we created. So these are all angles which are within one of these domains. So that's great. But what we're gonna do with it? So the output here is index and neighbor. All right, let's check what that means. If you want to know more about this, of course, you can get a panel and have a look what's in here. It shows you in which domain each of these numbers are. So each of these angles are. So the first angle is in the second domain. The next one is in the third domain. The third one is in the domain 0, like the first domain. Actually, second is the third and third is the fourth. Anyway, it starts with 0, 1, 0, 1, 2, 3, 4, and so on. So that is one thing. And neighbors gives us the same output. Okay. Anyway, so it tells us in which domain is each of these numbers. Okay. Now we need a list item to make sure that we can actually map colors onto this. A list item. Now index, very clear, needs to go to index. And now the list. What is the list? Okay. What we need to do, we need to merge data. and that goes into the list here. So how many domains do we have? Let's go back here again. Panel 1, 2, 3, 4, 5, 6, 7, 8. We start with 0. We have eight domains from 0 to 2.86 until 45 to 90, and all be in between. That means we can now apply colors to it. We can get a color swatch. So you could now say, okay, from 0 to 2.86, I want to have it's green. I want green. That is my first one. Copy. You can see as soon as I do this, a third one pops up. I can change this now. I can say, okay, I want this to become more blue. And then next one, and last one. 8 domains, right? It's a bit confusing because here's set 7, but because we count the 0, so we need to have 8 domains. It's always like when something happens like this, I'm struggling. Always like, what's going on? But yeah, that's how it works. Now we can put this list in here, and we have now a list of colors. So we get the index, and the index will give us the colors per entry, per list item. So because again, we get the first number is in the domain range. The third one, it says 2, but it's a 0, 1, 2. It's in the third domain, and the third domain has the color blue or light blue, right? So that color is 0, it's an RGB color, 0, 187, and 255. That's this color here. You could also put here a panel to see what's in here, right? So again, 0, 187, 255. That's what I said before. So you can see the first item, which is here number 2. We know number 2 is the third domain, and that's why it's the color light blue. So cool, we have now a color for each of these mesh faces. Okay, what's the next step? The next step is constructing the mesh, reconstructing the mesh. So we have deconstruct mesh, and we have a construct mesh. Analysis and primitive. There's construct mesh. For that, we first need to reassemble what we had here. So we need the vertices and the faces, and that will recreate our mesh. And it has, because it's so amazing, it also has a color input. And now we can just place the color input here. Whoop! It looks different because I use different colors here. I actually like these colors better. But green, but now you can measure, you can actually see what is what. So blue, dark blue, for example, here, green is flat. This turquoise is starting to get a bit of, it's a slope where you then already need a ramp, or let's say a handrail, and then it becomes steeper and steeper until quite steep. Actually, we don't have really red. Yes, we have a little bit, but actually this is still within the 45 degrees, it seems like. But yeah, that's the tool. Now, if you want, you can also blur the mesh, and that blurs the colors and makes it a bit nicer if you want to do if you want to show it somewhere in your, I don't know, presentation, you can then do that like that. For presentations, this is perfect, but I would almost like say this is more useful because it shows you a bit exactly when or where it transitions into the next, whereas this one is slightly less accurate. And you can increase how much blur you have. Let's try that. I haven't tried that. Let's see if I do this. Okay, that's not very useful then at the end. But yeah, you can blur this quite nicely. Now I can show you very quickly on how I could translate a list of slope ratios to get the same list. So if I have slope ratios, then the next step here would be we need to first translate that. So we can translate this by having a equation. Oops. And we write here a tangents 1 divided by x. And this is my x. What that does is to translate my slope ratios into radians. And now I can just translate it again like I did before. Degrees, radians, degrees. Okay. And now it becomes a bit tricky because the problem is I have here 0.001 because you cannot express 90 degrees with ratios. That doesn't work. So that's why I have this very strange number, but that's okay. So we have this. Now, as you can see, this is a bit different because here we have a 0 in front. How can we, because if I would now take this and put in my numbers, I would get this. It wouldn't start with 0. It would start with the 1 to 20 ratio. But that's, of course, that's not gonna work. So if I put this in here, I will run into the problem that as soon as I have not enough domains. So how to deal with this? We need to add here a number. We need to add a 0 to change that output. Now this is actually very simple. It's a very simple way to do. We just need to need a tool called insert item. And now we have a list and we need the number we want to add. We can just use a panel here, or you could use a number input. It also works. Oops. So now we have an output 0 because we want to add a 0 at the beginning of the list and put this in here. And we also need to tell it where it goes. So at the index, I need to tell it where in the position of the list it needs to go. And now we have a list which works exactly like the other one. So that's the way on how you could calculate slope ratios into degrees. So that's another way to do it. So the output here, now you can see it starts from 0. It just doesn't hit 90 at the end because that's not how it works. But you replace an item. That would be also possible. If you take out one of these, if you take out the last one, you add 90 to the list. You could do that as well. But I leave that to you as a homework. All right, here you have your slope analysis tool. If you don't have time to rebuild it, check out the link in the show notes. You can download it for a small fee. If this helped, like and subscribe, or check out the membership options if you want to support more tools like this. Your membership doesn't really buy me a coffee, but it allows me to keep doing these videos. See you in the next video. Ciao.